Okay, so this is a disease report on diphtheria by me, Deshanika Wash. The symptoms and signs of diphtheria. There is there's a pseudomembrane that forms on the larynx, pharynx, or tonsils when you have diphtheria, and it also a bull neck is kind of the hallmark um, sign of diphtheria. As you can see, this little boy's neck is swollen. His lymph nodes. There's a lot of swelling and inflammation in his lymph nodes. Very severe diphtheria can cause heart, kidney, and nervous tissue damage. And some other symptoms and signs are nasal drainage, stridor, sore throat, and fever. So there are two types of diphtheria. There's cutaneous diphtheria and respiratory diphtheria. Cutaneous diphtheria causes ulcers, and kind of like this ulcer that's on this guy's ankle. And it's not reportable. It's not a really prevalent or harmful disease in the United States. Um, and respiratory diphtheria was actually very harmful with very high mortality and morbidity rates in the United States before the diphtheria vaccine was introduced. Um, Killed many children under the age of 15. And the hallmark sign, like I said, of respiratory diphtheria is the bull neck and this pseudomembrane right here. It's made out of inflammatory cells, the actual bacteria that causes diphtheria, and fibrin. And it can also spread and obstruct the airway, which can is part of the thing that can make the disease fatal. So the bacteria that causes diphtheria is the Korean bacteria Diphtheriae. I probably said that wrong, but that's okay. C. diphtheria is a gram-positive facultative anaerobe. It's bacillus shaped, as you can see in this picture. It can infect really any part of the body, but it's mainly will affect mucous membranes, which is the respiratory diphtheria, where that comes from. And it can be spread by droplet and direct contact. The reservoir is humans. There's no other known reservoir of diphtheria. And it's also lysogenic. So the only way that the actual diphtheria bacteria can be can produce toxins is if it's infected by a bacteriophage, which I thought was pretty interesting. So unless C. diphtheria is infected by a bacteriophage and that carries the toxigene, then that bacteria will not produce the toxin. So so the C. diphtheria is actually lysogenic. In the taxonomy, Corynebacterium is a type of actinobacteria. It can infect animals, plants, and it can also be a part of your normal microbiota. So as for the history of diphtheria, diphtheria used to be the primary cause of child mortality before the 1920s, and that's actually when the vaccine was introduced. And it was prevalent in this area right here, the Pacific Northwest, Northern Plains, and the Southwest. The last notable outbreak was in the 1970s, and really, like I said, since the vaccine was introduced, we have not had a problem with diphtheria in the United States, but it is still prevalent. It's still endemic in other areas of the world, like Africa, the Caribbean, Latin America, Eastern Europe, and Southeast Asia, and even in Canada. So vaccinations. An inactivated toxin is delivered through the vaccination, and since it's inactivated, booster shots must be given every 10 years after the age of 15. Different, and like I said before, the incidence of diphtheria has decreased dramatically since the vaccination was introduced. Different types of vaccines are given for different age groups. If you begin your vaccinations in childhood, you'll be given the DTaP. And if you begin your vaccinations in adulthood, you'll be given the TD, series of 3 TD shots. The Tdap and TD shots are both booster shots, and it stands for diphtheria, tetanus, toxoid, and pertussis. And so yeah, the only real difference between Tdap and Td is that the Tdap has added protection against pertussis. So to diagnose diphtheria, a physician or a healthcare worker can measure antibody levels. If the person has more than zero point zero 0.01 IUs per mil of the antibody in their blood, then they are immune to the disease and probably do not have diphtheria. A positive diphtheria culture is necessary to confirm diphtheria, and an ELIC test is necessary to determine whether the bacteria is producing any toxins. So, probable cases are cases that have not been confirmed by a culture. So, for treatment, early identification is key to treating any disease. And with early identification, you can see who the person came in contact with. You can get better specimens. You can get pieces of that pseudo membrane, or if you can't, you can swab up under the membrane and get some cells from there. Better treatment is you're going to get better treatment if the disease is identified early, and also you people can be prevented from spreading the disease with early identification. And since diphtheria is a bacteria, so it can be treated with antibiotics. Penicillin and erythromycin are the antibiotics that are given, and diphtheria must be treated. Any probable cases or confirmed cases must be treated with the antitoxin. And the diphtheria antitoxin is actually made in horses, which I thought was kind of interesting, and it must be obtained from the CDC. So as for pathogenesis, diphtheria is a B toxin, which means it has two components. Fragment A inhibits protein synthesis in the host cell, and fragment B helps fragment A get into the cytosol of the host cells so that it can disrupt protein synthesis. So here's a bigger figure. Here's fragment A, and the blue part is fragment B. So the way this toxin works is that it's cleaved at the surface of the host cell, and it's endocytosed into the cell via receptor-mediated endocytosis. And once it's endocytosed, um, the fragment B helps fragment A cross the membrane of the endosome so that it can get into the cell. Now, the mechanism, like how exactly that works, is not fully understood. How the fragment A gets out of the endosome, it is thought that fragment A will unravel and slide through that lipid bilayer and then refold. And if it does do that, I thought that was pretty interesting as well. So, all cases of diphtheria, all probable and confirmed cases, must be reported. They like to conduct investigations on every case. They want to know the demographics of the person, where the disease was reported, the location, health history, anybody that the person's been in contact with, vaccination history, laboratory tests, and treatment. They need to know everything, just for the sake of epidemiologic reports, and everything must be reported to the NNDSS. So, here are the references, just in case you guys want. Okay, so I would just like to differentiate between the formal name and the common names. The formal name is Corynebacteria diphtheriae, and the common name is diphtheria, or respiratory diphtheria, or cutaneous diphtheria, depending on what type the patient has.